In section 5.7, you will apply the fundamental theorem of algebra and answer this question. How many solutions does the equation 0 equals x to the fourth plus 8x squared minus 5x plus 2 have? The fundamental theorem of algebra and its corollary tells us that the number of solutions is the same as the degree of this polynomial equation. So since it's degree 4, we know that it's going to have 4 solutions. Now the next question is really asking the same thing. It says how many zeros does the function h of x equals negative x to the 12th power plus 7x to the 8th power plus 5x to the 4th power minus 8x plus 6 have? So the degree of that function is 12 and the number of zeros, which are also solutions, is 12. So we can expect to find 12 zeros for h of x. Here we're going to find all real zeros of f of x equals x to the 5th minus 4x cubed plus x to the 2nd minus 4. And so we can expect to find 5 zeros because this is a function of the 5th degree. So factoring and using the zero product property, it's a polynomial in 4 terms. I'm going to use grouping. I'm going to try grouping. Taking out the greatest common factor in the first 2 terms, that's x cubed. So I'm left with x squared minus 4. X cubed times x squared is x to the 5th. X cubed times negative 4 is negative 4x cubed. The greatest common factor in the last 2 terms is 1. So I'll factor that out. And I see that grouping is going to work because I have binomials that are the same in the 2 products that I created. So I'll factor out the binomial x squared minus 4 now. And when I factor that out, I'm left with x cubed plus 1. Okay, now completely factoring. This first binomial is a difference of 2 perfect squares, so we need to factor that into the sum and difference of the square roots of those 2 terms. X times x is x squared, and positive 2 times negative 2 is negative 4, and remember 2x and negative 2x sum to 0, so there's no middle term in that binomial. Okay, the second binomial is a sum of 2 perfect cubes, so that'll factor into a binomial times a trinomial, and that binomial we get by taking the cube root of those 2 terms. So the cube root of x cubed is x, and the cube root of 1 is 1. Now the trinomial we get by squaring the first term in our binomial, multiplying it to itself. Middle term we get by multiplying those 2 terms together and changing the sign. So I'm going to get negative x in the middle. And then the third term, remember, we square the second term in the binomial or multiply 1 to itself. So I'm getting positive 1. And that quadratic trinomial, when it comes from the sum or difference of 2 perfect cubes, never factors further. So our function is completely factored and we're ready to use the zero product property. So I'll set x plus 2 equal to 0, x minus 2 equal to 0, x plus 1 equal to 0, and this trinomial, x squared minus x plus 1 equal to 0. Okay, solving the first 3 equations for x, I know that x is equal to negative 2, positive 2, and negative 1. Okay, but this quadratic equation needs to be solved using the quadratic formula since it doesn't factor. So x is going to equal negative b, and b is negative 1, plus or minus the square root of b squared. That's negative 1 squared, so that's positive 1, minus 4 times a, which is 1, times c, which is also 1, all over 2a, or 2 times 1. Okay, so simplifying, minus and minus 1 is 1, plus or minus the square root of negative 3, 1 minus 4 is negative 3, all over 2. So I see that I have 2 imaginary solutions here, and I'll just put them in proper form. So I have 1 plus or minus, the square root of negative 1 is I, square root of 3, and I'll divide both of the terms in the numerator by that denominator 2 so that I leave my imaginary solutions in a plus bi form. 1/2 minus the square root of 3 over 2 I, and 1/2 plus the square root of 3 over 2i. So we accounted for those 5 zeros for this polynomial function of the 5th degree. 3 of them are real and rational, and 2 of them are imaginary. Now imaginary zeros will always come in these conjugate pairs. So if there's 1 imaginary zero, there's 2. Okay, here we're going to work the other direction. We're going to write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and 2 and negative 2 minus 5i as zeros. Now we just stated that if there is one imaginary solution or zero, then there's 2. So we have to consider the fact that negative 2 plus 5i is also a 0. It has to be a 0 of this function that we're going to write. So we have 3 zeros, 1 real rational 0 and 2 imaginary. So we're going to work backwards. We know that those zeros come from factored form. So we'll put them back in. X minus a 0. The first one is 2. X minus the second 0, which is negative 2 minus 5i. And x minus the third 0, which is negative 2 plus 5i. Okay, I'm going to have to do some simplifying in some of those sets of parentheses at the end here. Distribute. So I have negative 1 times negative 2, that's positive 2. I have negative 1 times negative 5i, that's positive 5i. Okay, and getting rid of the inner parentheses in this set of parentheses, I have x. Negative 1 times negative 2 is positive 2 again. And negative 1 times positive 5i is negative 5i. Okay, I need this function in standard form, so I'm going to have to do all the distributing. And I'm going to start by multiplying the two sets of parentheses together that have the imaginary number in them. So I'll distribute x times x is x squared. X times 2 is 2x. X times negative 5i is negative 5ix. Okay, now I'll start over with 2. 2 times x is 2x. 2 times 2 is 4. And 2 times negative 5i is negative 10i. And one more time, distribute 5i through that trinomial. 5i times x is 5ix. And 5i times 2 is 10i. 5i times negative 5i is negative 25i squared. Okay, now I need to add like terms. So I've got my x squared term. I have positive 2x added to positive 2x, that's positive 4x. Negative 5ix and positive 5ix come to 0, so they cancel each other out. Negative 10i and positive 10i also sum to 0, so they cancel each other out. And then I have I squared, which is negative 1. Negative 1 times negative 25 is positive 25, and I'll add that to that constant 4, so getting a total of 29. Okay, we have to distribute again. Binomial times a trinomial. X times x squared is x cubed. X times 4x is 4x squared. And x times 29 is positive 29x. Start over with that negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times 4x is negative 8x. And negative 2 times positive 29 is negative, let's see, 18, 4, 5, negative 58. So adding like terms one last time, we have our function of the third degree, and we started with 3 zeros, remember, so our function is going to be of the third degree. 4x squared and negative 2x squared is positive 2x squared. 29x minus 8x is 21x. And my constant term is negative 58. So there's the polynomial function f of least degree that has rational coefficients and a leading coefficient of 1. Here we're going to determine the possible number of positive real zeros, negative real zeros, and imaginary zeros for this function f. We know that it can have 6 zeros, that it has to have 6 zeros, but how many positive zeros can we expect? Negative zeros, and imaginary zeros. We'll make a little chart to determine the possibilities. Okay, so to test for positive real zeros using Descartes' rule of signs, we look for the changes in sign in the terms of f. It starts out with a positive leading term, then it changes to negative terms, 2 of them, and back to positive. So that's one change, and then back to positive, that's 2 changes. Now there's 2 positive zeros or less than that by an even number. So 2 minus 2, an even number, would leave 0. So we could have 2 positive zeros or 0 positive zeros. Okay, now we need to test for negative real zeros, so we have to look at f of negative x to do that. So in our function we substitute negative x in for x and simplify. Okay, and when I simplify, f of negative x is going to have a positive first term because I have an even number of negative factors, so that's going to stay 2x to the 6th. Second term, I have an even number of negative x's, so that's going to be positive x squared multiplied to negative 3, so that's going to stay a negative 3x squared also. But this third term is minus x, so that's going to be positive x and positive 1. So the changes in sign in this function starts out positive, next term is negative, and back to positive. So it looks like 2 changes again, from positive to negative and back to positive. 2 changes, which means there's 2 negative real zeros or less than that by an even number, 2 again. So we could have 2 positive real zeros and 2 negative real zeros, or we could have 0 positive real zeros and 2 negative real zeros, or we could have 2 positive real zeros and 0 negative real zeros, or 0 positive real zeros and 0 negative real zeros. Those are our combinations. Okay, because there has to be 6 altogether, if I have 2 positive and 2 negative, I can expect to have 4 imaginary zeros. Oops, not 4, 2 imaginary zeros. And here I have 0 positive and 2 negative, so there's where I'm going to need 4 imaginary zeros to finish that out. I need 6 zeros altogether for this function of the 6th degree. 2 positive, 0 negative, that's going to mean 4 imaginary. And here, 0 positive, 0 negative, I'm going to need all 6 of my zeros imaginary. So those would be all the possible number of positive real zeros, negative real zeros, and imaginary zeros for that function of the 6th degree. Include with your notes of this video guided practice problems 1 through 9 odd found on pages 379 to 382 of your textbook.